Hi everyone, welcome back to my channel. This is my second video on the YouTube. In my previous video, I have shown how to create EC2 instance using the AWS console as well as Terraform. In this video, we will be seeing about VPC. How to create VPC using AWS console, and we will be using Terraform to achieve the same thing. What is VPC? VPC stands for Virtual Private Cloud, and the size of the VPC depends upon the IP address range. Those who don't know what IP address is, IP address enables the resources to communicate with each other over the internet. Now to understand the VPC in much better way, as a metaphor, if I want to keep my resources to be secure, means it should be private and should only be accessed by me, then I need to keep my resources in the private cloud. If I keep my resource in the public cloud, what will happen is everyone can access it and it will lead to a security breach. So to overcome the security type of thing, I will keep my resources in the private cloud. In technical terms, company runs applications on servers and they don't want their applications to be exposed completely. So they maintain such application servers in their own data centers, which is also called as on-premise. So this was the traditional way of maintaining applications resources privately, like maintaining their own application servers inside their own physical data centers. But these days companies are moving towards the cloud, and AWS is the first cloud provider who came up with an idea with this resource named Virtual Private Cloud. Companies are moving towards the cloud. Okay, what's the actual difference between the cloud and the physical data centers? So in the physical data centers, as I have said, companies used to maintain their own physical data centers. They used to maintain each and everything manually. Okay, and the maintenance cost was huge. But when it comes to cloud, company needs to pay the charges, but based upon the usage of resources. Rest all the maintenance things, all the security things will be taken care by the cloud itself. Okay, here we are using AWS cloud. So when we will be creating the VPC, right, we will be requesting AWS to create private cloud where we can keep our application securely. So that's it regarding the VPC. Next, what is internet gateway? So we have created the VPC, we have placed our application inside the private cloud. Okay, now to access the application we need an internet. Without internet, no one can go inside the VPC and access their application. So what internet gateway does is, it provides the path for the network traffic to travel between the VPC and the internet. Okay, so with the help of internet gateway, user can enter inside the VPC and can access the application. So what we have done till now, we have created the private cloud, and inside the virtual private cloud we have placed our application securely. Now to access the application, we are using the internet gateway to get inside the VPC, and we are accessing the application. Coming to the subnets, there are two subnets, public subnet and the private subnet. Okay, public subnet is a subnet to which anyone can have access. Okay, now coming to the private subnet, this is the subnet where we will be keeping our applications securely, which means the applications will not be exposed to the internet. Now coming to the route tables, if I have to say in simple terms, if you are in the marketplace, now to reach your home, you will be following some of the path or a route to reach your home, right? In the same way, as a user, we will be defining the rules inside the route tables, how the request should flow towards the application. We will be seeing this much more in a practical way when we will be creating the VPC. Now coming to the NAT gateway, NAT stands for Network Address Translation. Now the resources which are inside the private subnet cannot have access to the internet. But how the resources will download the things from the internet? It will take the help of NAT gateway. NAT gateway helps the instances or the resources inside the private subnet to download the things from the internet. So with the help of NAT gateway, the resources which are present inside the private subnet can connect to the internet and download the things. But the resources which are outside the VPC cannot communicate to the resources inside the private subnet. Let's understand what is the difference between internet gateway and the NAT gateway. Internet gateway allows both inbound and outbound access to the internet. When it comes to NAT gateway, it will only allow the outbound access to the internet. Now what is inbound and outbound access? Inbound access is nothing but the request going towards the application is the inbound access. The request coming out of the application is the outbound access. I hope you have understood till now. So let's move on to the practical and let's see how to create the VPC how to create internet gateway and attach internet gateway to the VPC, how to create the subnets, how to create route tables, how to associate the subnet to the route tables, and how to attach the NAT gateway to the private instances. I'm in the console right now. To create VPC, go to the search, give VPC, click on VPC, click on create VPC. In two ways you can create the VPC. One is VPC only, another is VPC and more. So with this option VPC and more, route tables, subnets, everything will be created automatically. Okay, but I won't be using this option. I will be using VPC only option. So let me give the name for the VPC, test VPC. As I have said earlier, the size of the VPC depends upon the IP address range. So we need to provide IP address over here. So we need to provide the CIDR range over here. So CIDR is nothing but classless inter-domain routing. I will not touch these options. I will leave these options as default. Click on create VPC. VPC has been created. Now I will create the internet gateway. So without internet gateway, no one can enter inside the VPC, right? So to enter inside the VPC, we need to go through the internet gateway. So click on create internet gateway. Provide the name for the internet gateway. I will give as test IGW. Click on create internet gateway. Internet gateway has been created. I will attach this internet gateway to the VPC. As the state of the internet gateway is detached, we need to attach it to VPC. Go to actions. Click on attach to VPC. Select the VPC which you have created. Click on attach internet gateway. So the state is attached, which means the internet gateway is attached to the VPC. So we have created the VPC, we have created the internet gateway and attached the internet gateway to the VPC. Next, I will create the subnets. As I have said, there will be two subnets. One is public subnet and other is the private subnet. So I will create two subnet over here. One is public, other is private. Select the VPC, this one. Provide the name for the subnet. I will provide name as public for the public subnet. As I have said, AWS has multiple regions and each region will have multiple availability zones. Availability zones are nothing but data centers. Okay, so select any of the availability zones. I am in the AP South 1 region and AP South 1 region has three availability zones, 1A, 1B and 1C. I will go with 1A. This is the VPC IP address range. Okay, now let me give the subnet IP address. So 10.0.1.0/24. Click on create subnet. Public subnet has been created. Now I will create the private subnet. Click on create subnet. Again select the VPC. Provide the name. I will provide it as private. I will select availability zone as 1A. IP address I will provide as 10.0.2.0/24. Click on create subnet. So we have created two subnets. One is public and other is private subnet. But for the public subnet, select the public subnet, click on actions, go to edit subnet settings, click this checkbox, enable auto assign public IPv4 address, click on save. So with this, whenever we will create the resource using this public subnet and public IP will be assigned to that resource. Okay. I will not do it for the private because if I do it for the private, right, it will assign the IP addresses to the resources, public IP. But I don't want that resource to get the public IP, which I want to be secured. I have created the subnets now. Let's create the route tables. Click on route tables. Click on create route table. Provide the name. I will provide it as public route, RT, route table. Select the VPC, the new one which we have created. Click on create route table. I will create the other one which is a private route table. Select the VPC. Click on create route table. We have created the subnets. We have created route tables. Now let's associate the subnet to the route tables. Select the public route table. Go to subnet associations. Click on edit subnet associations. Select the public subnet. Click on save associations. Same do it for the private route table too. Click on private route table. Go to subnet associations. Click on edit subnet associations. Select the private subnet. Click on save associations. With this, we have associated the subnet to the route tables. Let's create the NAT gateways. Click on create NAT gateway. Provide the name. I will provide it as NAT. Now in which subnet you want the NAT gateway to get created. As I have said, NAT gateway helps the private instances to connect to the internet. To connect to the internet, the NAT gateway should be placed in the public subnet because public subnet will have the internet access. So select the public subnet. Now, when creating the NAT gateway, we need to provide the elastic IP. So click on allocate elastic IP. Elastic IPs are the static IPs. Okay. As a metaphor, I have created the instance and I have restarted the instance. Public IP address of that instance will be changed for every restart, which means that instance is using the dynamic IP. If I use this elastic IP, no matter how many times I restart the instance, IP address will be same. But this is chargeable. The NAT gateway is chargeable. Even this elastic IP is also chargeable. So click on create NAT gateway. We have created the VPC. We have created the subnets. We have created route tables. We have associated subnet to the route tables. We have created internet gateways. We have attached that internet gateway to the VPC. We have created the NAT gateways. Okay. Now what we need to do is we need to provide the route path so that the request can flow towards the application which is inside the private subnet. Okay. So click on route tables, go to public route, go to route, click on edit route, click on add route. I will select anywhere. Okay. This is just for a demo purpose, but in real time we don't provide this IP address. Here for the target, in the drop down select the internet gateway. Select the internet gateway which we have created. Click on save changes. Now go to the private route table, go to routes, edit route, add route. In the drop down click on NAT gateway. Choose the NAT gateway which we have created. Click on save changes. We have created the NAT gateway in the public subnet. Okay, but here we are creating the route for the NAT gateway inside the private route table, as the application server will be inside the private subnet. Next, we have done everything over here. Like we have created the VPC, we have created internet gateway and attached it to the VPC. We have created subnets, we have created the route tables, we have associated the subnet to the route table, we have created NAT gateways, and we have created the route for the internet gateway and the NAT gateway inside the public and private route tables. Now go to your VPCs, select the test VPC, click on resource map. It will show all the graph over here. So these are the things which we have created till now. We have created VPC, we have created the subnets, public subnet and private subnet. We have created the route tables, public route table and private route table. We have created internet gateway, we have created the NAT gateway. As I have said earlier, to enter inside the VPC we require the internet gateway, right? So we have created the internet gateway and attached that internet gateway to the VPC. Once the user enters inside the VPC, user will have access to the public subnet first. I have created the public subnet, I have created the public route table, and I have associated the public subnet to the public route table. If the resources are present inside the public subnet, so there has to be a proper route so that the request of the user should go towards the application, and that route we have mentioned inside the public route table by making the route entry of test internet gateway. Okay, but we have given destination as 0.0.0.0/0, but in real time we provide the resource IP address over there. Keep in mind. Okay, now coming to the private subnet, we have associated this subnet to the private route table and we have made the route entry for the NAT gateway. Okay, if the user wants to access the resources inside the private subnet, the request should go towards the application, right? And the request should follow some of the path. So that path or route is mentioned inside the private route table. We have made the route entry for the NAT gateway inside the private route table. Okay, because NAT gateway helps the private resources to connect to the internet to download the things, but the external resources cannot access the resources which are present inside the private route table. I hope you got it. So this video was based upon how to create the VPC. That's it. I will not be creating any kind of instances in this video. In the upcoming video, I will be showing how to create the load balancer, how to attach the private instances to the load balancer as a target group. So that's it. Let's create the VPC using the Terraform. But before moving towards the Terraform, let's delete this VPC. Let me delete the route entry for the route table. Go to the public route, routes, edit route, click on remove, save changes. Same for the private route table, routes, edit route, remove, save changes. I will go to the NAT gateways and I will delete it. Actions, delete NAT gateway. NAT gateway is deleting. It will take time for the NAT gateway to get deleted. Let's move on to the subnets. Select the public and private subnet. Click on actions. Click on delete. Now both the subnets have been deleted. Go to the route tables. Go to route tables. Delete the route table. Actions, delete. We can delete the subnets and the route tables one by one. So the public and private route tables have been deleted. Go to the internet gateway, detach the internet gateway from the VPC and then delete it. So the NAT gateway has been deleted. So let's release the elastic IP, or else I will be charged for this as it is chargeable. Select the elastic IP, go to actions, click on release elastic IP, release. Next, go to your VPC, select the VPC, go to actions, click on delete. So the VPC is deleted too. Let's move towards the Terraform and see how to create the VPC using Terraform. To create resources with the help of Terraform, first we need to specify the provider block over here, because without provider block, Terraform can't go ahead and create the resources, because Terraform works with provider plugins. Okay, so specify the provider block over here, provider, and which provider we are using AWS. So provider AWS, and what are the things we need to mention inside this provider block? There are three things: region, access key and secret key. I will be creating the resources in the AP South 1 region. We need to create the secret key and access key. In the previous video, those who haven't watched that video, kindly go ahead and watch that video. In that video I have shown how to create the access key and secret key. So access key and secret key, you need to mention over here. But remember, in the real time, we don't have to mention this directly in the main configuration file. Let me just copy paste the keys. I have copy pasted the keys over here. Let me show the official documentation of the Terraform. I am in the official documentation of the Terraform AWS. Just go to AWS provider. So this is the provider block which I am using in my configuration file. Provider AWS, and it contains three things: region, access key, and the secret key. That's what I have mentioned over here. Once the provider block is mentioned, we need to create the resources. First, we need to create VPC. Go to the official documentation, search for the VPC, Control F, VPC, Virtual Private Cloud. AWS_VPC is the resource type for the VPC. For this resource type, we need to mention the CIDR block. As I have said, the size of the VPC depends upon the IP address range. We need to mention the CIDR range over here. Okay, we can mention the tags: resource AWS VPC. This is the resource type for the VPC, and let's give the local name for the VPC. Let's say main. That's it. Let's mention the IP address over here. I mean CIDR block. Let's take CIDR block or IP address range as 10.0.0.0/16. Subnet mask value. Let's give the tag as tags is equals to curly braces. Name I will give as VPC_TF. So VPC will be created. After VPC, what we have created? We have created the internet gateway. So let's create the internet gateway. Resource type for the internet gateway will be inside the AWS_VPC only. Just go to the browser. You need to create the internet gateway. Okay. So this is the internet gateway. AWS_internet_gateway is the resource type for the internet gateway. AWS_internet_gateway. Let's give the local name, which will be main_IGW. Provide the name like tag. Let's provide the name as IGW_TF. After creating what we have done, we have attached the internet gateway to the VPC. So let's attach resource. As we are attaching internet gateway to the VPC, so the resource type will be AWS_internet_gateway_attachment. So let's give the local name. As we are going to attach the internet gateway to the VPC, we need to mention the VPC ID over here and the gateway ID over here. So the VPC ID will be VPC_ID is equal to, here we will be using the implicit dependencies. So implicit dependencies are nothing but we are referring to the other resource. So VPC_ID. This ID will be generated once the VPC is created. Let's refer the AWS_VPC resource type over here. Okay. AWS_VPC dot. Let's give the local name main. Once the VPC is created, it will have one ID. So mention the attribute as ID. How I know the attribute will be the ID? Just go to the official documentation, go to AWS VPC, scroll down, go to the attribute reference ID. ID refers to the ID of the VPC. So this way it's better to follow the official documentation also whenever you are practicing the Terraform. So I mentioned the ID over here. So first the VPC will be created, then when the internet gateway is created, it will go and attach to this VPC. As I have given the resource reference over here. Referring one resource to the other is nothing but implicit dependencies. Which gateway we are attaching it to the VPC? We need to mention over here. So we need to mention the internet gateway ID. Again, we will be using the implicit dependencies over here. Let's refer the AWS internet gateway resource type over here. AWS internet gateway dot. Let's give the local name of the internet gateway main_internet gateway dot ID. So once the internet gateway is attached, okay, this internet gateway ID will be attached to the VPC ID. VPC will be created. Gateway will be created. That gateway will go and attach to the VPC. Next, let's create the subnet resource. The resource type for the subnet will be AWS_subnet. All these things will be in the official documentation of the Terraform. Just refer to that. Let's give the local name. Let's give it as public. For now, let's create only one public and one private subnet. While creating the subnet, we have mentioned the IP address and we have selected the VPC. Give the VPC ID over here. While creating subnet manually, we have selected the VPC and we have provided the IP address for the subnet. Again here, we will be using the implicit dependencies. So VPC_ID. So need to refer the VPC resource over here. So AWS_VPC dot main.id. Let's give the IP address range. CIDR block. Here I would like to show one tool or one website where you can easily get the subnets for the specific IP address. Just copy the IP address we have mentioned for the VPC. Copy it. So this is the website where you can go ahead and you can divide your IP addresses and use that IP addresses for your subnet. So 10.0.0 mask bit will be /16. Click on update. Click on divide, as I will be creating one public and one private. I will be using this for public and this for private subnet. I will provide this website link under the video description. I will paste it over here. Let's give the tag for this subnet. Let's give it as public_TF. Let's create private subnet now. So resource AWS subnet. Let's give the name as private for the local. Whatever we are giving the local name for the resource type, these local names will be present inside the Terraform.tf state file. Let's give the VPC ID over here. Because when we created the subnet, we have selected the VPC, we have provided the IP address range, and there was a tags option also, but we haven't touched that. Here we are using the tags option. VPC ID is equals to AWS underscore VPC underscore main.id CID block. Let's give the second IP. This is the subnet address. Let's give this address for the private. Let's give the tag. Give the tag as private TF. So we have created public and private subnet. Let's create public and private route table. So the resource type for the route table is AWS underscore route underscore table. Let's give local name as public underscore RT. Provide the tags for this. Create one more route table, private route table. Let's provide the tag. Let's enclose rest other tags inside the code. Subnet has been created. Route table has been created. Let's associate the subnet to the route table resource. The resource type for the subnet association is AWS underscore route underscore table underscore association. Let's provide local name as associate 1. Here, if you remember, when we were associating the subnet to the route table, we selected the route table, we went to the subnet association section, we clicked on edit, we have selected the public subnet and we clicked on save changes. So here we need to mention the subnet ID. So to which subnet, here we need to provide the subnet ID. Okay, subnet ID is equal to, again we need to use implicit dependencies, referring the one resource to the other. So AWS subnet, let's associate the public subnet to the public route table. So we will be taking public subnet one. What is the local name for the public subnet? It's public. Once the subnet is created, it will have one ID. So we need to refer that ID over here. .id. To which route table we are going to associate this public subnet? To the public route table. Again, we need to provide the route table ID over here. Again, we will be using the implicit dependencies AWS route table dot public route table, right? So local name for the public route table is public underscore RT. Once the route table is created, it will have one ID. So we are referring that ID over here. .id. With this, the public subnet will be associated with the public route table. In the same way, we need to associate private subnet to the private route table. Just copy it. Let's change the local name, associate to. That's it. With this, the private subnet will be associated with the private route table. We have created the route table. We have associated the route table. We need to make the route entry. But before making the route entry, let's create the NAT gateway. As you remember, when we have created the NAT gateway, we have provided the elastic IP allocation ID, right? For that, first we need to create the elastic IP. Resource type for the elastic IP will be AWS underscore EIP. Let's give the local name as EIP. So domain is equals to VPC. We need to give domain over here as VPC. Let's create the NAT gateway over here. The resource type for the NAT gateway will be AWS underscore NAT underscore gateway. Let's provide the local name as main underscore NAT. Here we have given the allocation ID. Okay, so allocation ID. What was the allocation ID we have provided over there? We have provided the elastic IP allocation ID. So again, we need to use the implicit dependencies. We need to cross reference the resource name over here. AWS underscore elastic IP underscore dot local name EIP dot ID. Provide the tag for the NAT gateway. Tags is equal to name equals to NAT underscore TA. Now let's make the route entry for the internet gateway and the NAT gateway. For the route entry, the resource type will be AWS underscore route. Let's give the local name as route. First, I will create the route entry for the internet gateway. For that, we need to provide the internet gateway ID over here. As usual, here also we will be using the implicit dependencies. Gateway underscore ID is equal to AWS underscore internet gateway dot main underscore IGW dot ID. We have made the route entry for the internet gateway inside the public route table. So route table ID, let's refer to the public route table resource type. So AWS underscore route underscore table dot public local name public underscore RT dot ID. We have made the route entry, but there is one thing over here. We have provided the destination CIDR block. Destination CIDR is equal to, we have provided for everything. As I said before, in real time, we will be providing the resources IP address over here instead of everything. For a demo purpose, we are using this 0.0.0/0. We have made the route entry for the internet gateway. Let's do the route entry for the NAT gate, but inside the private route table. I will be copying this. I will paste it. I will change the local name because local name should always be different. Let's go ahead and provide the NAT gateway ID. Local name was main underscore NAT dot ID. We need to do the route entry inside the private route table. The destination CIDR will be same. We will be creating the VPC. We will be creating the internet gateway. The internet gateway will be attached to the VPC. So two subnets will be created, public subnet and private subnet, and two route tables will be created, public route table and the private route table. We will be associating the public subnet to the public route table, private subnet to the private route table, and we have created the NAT gateway. For that NAT gateway, we need the elastic IP allocation ID. For that, first we will be creating the elastic IP, and then we will be using that elastic IP ID over here to create the NAT gate. Then we made the route entry for the internet gateway inside the public route table, And for the NAT gateway, we have mentioned the route for the NAT gateway inside the private route table. Hope it is clear. So one more thing over here. I have mentioned the implicit dependencies in this way, right? The resource type, then the local name and the attribute reference. You can even mention this in a different way using interpolation. I have told you before the interpolation. Here let's use the interpolation. Dollar curly braces. Let's mention these things inside the curly braces. Let's save the file. The first command is Terraform init. What it will do is it will go and download the provider plugin. So which provider plugins? As we have mentioned the provider as AWS, it will go and download the AWS provider plugins. It's throwing error. Let's see what I have done. We need to use the interpolation with the quotes over here. It's downloading the plugins, AWS plugins. Plugins have been downloaded. AWS plugins will be inside the .terraform directory. Under the .terraform, there will be a providers directory. In the providers directory, there will be subdirectories. And you can see over here, AWS with the version 5.71.0. We have downloaded the provider plugins. So with the help of these provider plugins, Terraform will go ahead and create the resources on the AWS. Next command is Terraform plan. This command will show which resources are going to get created on the AWS. So Terraform plan, put the error. Here we have given the wrong resource type name. As well it should be NET. That's the reason we are getting the error over here. And for the public route table, we need to mention the VPC ID also. And the NAT gateway, as we will be creating the NAT gateway inside the public subnet, we need to mention the subnet ID over here, public subnet ID. So I have missed that. Vi main.tf. So Terraform plan command shows the resources which are going to get created on the AWS, and it will also show what are the errors inside the configuration file before creating the resources, as we have seen over here. So let's correct those errors. First is internet gateway. Let's go and change the resource type name. Here. And for the public and private route table, we need to mention the VPC ID, which we have missed it. VPC ID is equals to, let's use interpolation, or else you can write normally also AWS VPC dot local name dot ID. Same for the private route table, we need to mention. Okay. And for the NAT gateway, we haven't mentioned the public subnet ID. So we need to mention the public subnet ID over here. Again, we need to use implicit dependencies. So subnet ID, cross-reference the public subnet ID, AWS underscore subnet. What was the local name for the public subnet ID? It was public. So public.id. Save the file. Again, let's run the Terraform plan command. I hope it will not throw error. Again, it throw the error. Let's see. Destination CIDR is not expected here. I guess we need to mention as destination CIDR block. So vi main.tf, it will be a destination CIDR block. Save the file. Let's see again. It will not throw error for sure. Yes. So it is showing 13 to add. Now create the resources. Let's use the command Terraform apply. And let's use the option auto approve, because after giving the Terraform apply command, it will ask for the approval. However, we need to go and create the resources, right? So let's give the auto approve option. It will go and create the resources directly without any approval pop up. See, it's creating directly. It's not even asking for the approval. Let's wait for the VPC to be created. VPC has been created. And along with VPC, other components has been created too. So let's check in the console. I'm in the console right now. Let's check whether the VPC has been created or not. Go to VPC, click on your VPCs. Yes, the VPC has been created. We have given the tag as VPC underscore TF. So VPC has been created with the IP address range 10.0.0.0/16. Let's check the internet gateway, whether it has been created and it is attached or not. So the internet gateway has been created and it is attached to the VPC. Let's check for the subnets. So public and private subnet has been created. Route tables. Yes, public and private route table has been created. Let's see the elastic IP. The elastic IP has been created too. Let's check for the NAT gateways. NAT gateway is created too. Now let's check the route entry for the route tables. So go to the public route table, go to routes. So we have made the route entry for the internet gateway inside the public route table. Let's check for the private route table. Go to routes. We have made the route entry for the NAT gateway inside the private route table. So this is how we can create the VPC using the Terraform. Let's destroy the VPC. So there is a command Terraform destroy. Let's give the option as auto approve. So it will not ask for approval. It will delete directly. The resources has been deleted. That's it for today guys. Signing off.